Okay, welcome back. In this video, we'll be talking about manufacturing process flow design, and be looking at manufacturing process analysis. So continuing with it. So if you have not watched the previous video, make sure that you watch the previous video. Right? So manufacturing process flow design is a method to evaluate the specific processes and how the materials flow through flow through those processes. So there are different ways in which you can represent manufacturing process flow. A few ways in which you can do it is looking at assembly drawings. So if you have assembly drawings, you sort of know these are the different parts that go into into the final product. So these are the different processes that you need to do to make the part that you have to do. Then you have an assembly chart which shows how the parts go together. And of course, you have an operation and route sheet which tells you how the different operations and processes are routed. And finally, you have a process flow chart which tells you exactly how the product progresses through the production facility. So we already seen process flow chart before, but let's look at the other. So this is what a sample assembly drawing looks like. It's simple enough. So for this, you'll have a sample assembly chart which tells you how this different how these different parts are going to get assembled. And then you have an operation and route sheet which sort of tells you, okay, this where the hole is going to get drilled, and then it's going to send from the drilling department, and then it's going to go and get deburred in the drilling department, and then you send it to the lathing department, and then to the tapping department, and back to the lathing department, and so on. So this is how it's going to flow, right? And finally, you have a process flow chart, and this is what the process flow chart looks like. And this is again similar to the one that we've seen before. So let's take an example of a manufacturing process, and let's do some analysis. So here is an example of a manufacturing process. So you'll notice that here there are two parallel things that are happening. One is your molding parts. So molding is done by the company. All the other parts are purchased from outside. So just molding happens here, but everything else is purchased from the outside. And once you have the outside parts and the molded parts, you assemble all the parts together. Now, we will assume that any inventory that we need from the outside, we will always get. So there is no dearth of inventory for parts purchased from outside vendors. The bottleneck is mainly from the molding of what you're going to do, and of course the assembly also, right? So here is a data about the assembly process. So for the assembly process, you have 15 workers working 8-hour shifts. Now the assembly line moves at the rate of 150 components per hour. So that's how many they can make. Now, we will talk about some of the costs, but we'll get back to the costs later. So the workers are paid an incentive pay of 30 cents for every good part they can make. Now there is an option of running a second shift of 15 more workers, but we'll come back to that option later. Right now, we'll just look at a 1 8-hour shift of 15 workers. So everything but molding is from the outside, from an outside vendor. So this part of the process is not under our control. We're just buying those parts. Now, so that's the assembly portion. Let's look at the molding process itself. So for the molding process, you have 11 machines, and one is always down for routine maintenance, and you need one operator per machine. So initially, when we do our analysis, we'll assume that there are 6 employees. We also have the ability of hiring 4 more employees to make it 10. So that we use all the 10 machines that are available. Now, this part of the process, you can make 25 parts per hour per machine. And then they are paid 20 cents per good part and an overtime cost of 30 cents per part also, in case that's something that we want to consider. So that is some of the costs. Now here are some of the remaining costs. So raw materials are 10 cents per cost, and electricity is 2 cents per cost, and all the other all the purchase components that you purchase from the outside, the purchase parts are 30 cents per component. Apart from this, you have some fixed costs per week. You have $100 per week of rental, $1,000 per week. Other employees receive $1,000 per week, so you have accounting and all the other people, bookkeeping and whatnot. And then you have a depreciation of $50 per week. So these are all the costs that you are going to incur. So using this, we want to answer these questions. The first is, first let's determine what is the capacity of the process, and we want to know if the capacities are balanced. And then what happens if you use all 10 machines instead of the 6 machines in the molding process, and then we'll talk about the assembly process where you could go to a second shift, right? So let's talk about that. So first, let's look at the molding process and let's calculate the capacity of the molding process. So to calculate the capacity of the molding process, notice that you have 25 parts per hour. So this is per machine. So you have 25 parts per hour times 6 machines, right? So 25 parts per hour times 6 machines. And you're working them 8 hours per day and 5 days a week. So because all the fixed costs are given as per week, we'll calculate everything per week. So the capacity of the molding process is 6,000 parts per week. Similarly, if you look at the assembly process, you are making 150 components per hour. Now that is for all the employees put together. We are not looking at each employee individually. Times 8 hours per day times 5 days per week. And so you can also make 6,000 components per week in the assembly process. So the molding process has a capacity of 6,000, assembly process has a capacity of 6,000. So the capacities are balanced exactly, right? So they're exactly equal to each other. So then in perfect balance, you'll buy 6,000 parts from outside and then you just assemble them all together, right? So we'll come back to costs later. Now let's answer these questions where it says, what happens if you use 10 machines instead of 6 machines in the molding process? So instead of 6 machines, if you use 10 machines, the capacity becomes 10,000 parts per week for molding, but the assembly capacity is still 6,000. So your whole process still has a capacity of 6,000. So adding those extra 4 people does not make sense, at least initially. Now, but you have the option of going to a second shift in the assembly process. What happens then? So if you go to a second shift in the assembly process, so you're basically doubling the capacity of the assembly process. So the assembly process capacity goes from 6,000 to 12,000. But if you add 4 extra people in molding, the capacity only goes up to 10,000. So molding will have a capacity of 10,000, assembly will have a capacity of 12,000. So the total capacity of the process will be 10,000 components, right? So total capacity, so, and the capacities are no longer balanced, right? So the total capacity of the process will be 10,000 per week. So that's how many items you can make. So for these two options where you have 6,000 items per week versus 10,000 items per week, what is the cost per unit? So this is a very important metric that you calculate when you're looking at assembly processes, which is what is the cost per unit? How much are you spending per unit, right? So we have raw material cost for molding. So I have these numbers here. So we have raw material cost for molding, parts purchased from outside, electricity, molding labor, assembly labor. So we have all of these labor costs right here. And then we have the fixed cost. So let's calculate the total cost. So if you have the number of components, let's do that. The number of components manufactured per week is 6,000, let's say. What is the total cost? So total cost will be the sum of all the fixed costs. So fixed costs don't depend upon the number of items that you make, plus the number of items that you manufacture times all the variable cost values. So you add up all the variable cost values, multiply them with the number of units that you manufacture, and then you add all the fixed cost values. That gives you the total cost, right? So total cost is 6,670. The number of components that you manufacture is 6,000. So cost per unit will be 6,670 divided by 6,000. So it will be $1.11. So that's the cost per unit if you manufacture 6,000 units per week. But let's say that if you're going to manufacture more, so let's say that if you manufacture 10,000 units now, then the total cost becomes 10,350. So the fixed cost remains the same. It's the variable cost that goes up. But this 10,350 is divided over 10,000 units. So now the cost per unit becomes $1.04. So this is original, this is increased capacity. Right? Okay, So as you make more items, your fixed costs get spread out over larger number of items, so your total cost per unit will go down. But in manufacture setting, there's a very, very important number. What is the cost per unit? Now this is something you'll come across. So let's say you watch Shark Tank, right? And they ask you, okay, what is the how much does it cost you to make one item? So this is exactly what they're asking them, right? And they'll say, can you get it done from by 50 cents? Can you get it done by 4 cents? So even even saving 5 cents or 10 cents here overall saves you a large amount of money. So the overall savings can be very, very high, especially when here we are looking at 6,000 or 10,000 units. But imagine if you're making millions or hundred tens of millions of units, then just shaving off cents can have a huge impact on your bottom line, right? That's it. So that's an example of manufacturing process and the analysis around it. So we calculated capacity the same way we did it with any process, any old process, like we did with Kristen's cookies. And here we calculated the cost per unit if you were given all the different costs that go into making this item, right? And that's manufacturing process analysis, right? So I'm going to end this video here. I will see you all in the next video, right? Take care.